So now we're going to take 20x squared and divide by 4x. So 20x squared over 4x. And 20 over 4 is 5. X squared over x is x. So we got 5x. So I'm going to put 5x up here, okay, above the x. So then we multiply 5x times this whole thing. So if you've done it right, then this number here, or this part here, is always going to be the same as the thing above it. It better be. If it's not, then you made a mistake, okay, and you need to fix it. So that means that this number would be wrong if that happened. And then 5x times -1, negative 5x. Okay, so we take the first term, divide by the first term, multiply, and then subtract. And remember, when you're subtracting a polynomial, that means I'm going to distribute the negative or change the signs. So the first part, this one is always going to be 0 then. And negative 13 plus 5 is negative 8x. And then I bring down the next term. Okay. And if ever you're missing one here, so if it said 20x cubed and then 13x, and there's no x squared, you'd put a 0 in there for x squared. Okay, so now I take negative 8x and divide by 4x. Okay, so I take the first term I've got here then, divide by the first term here. When I divide them, negative 8 divided by 4 is 2, and the x's cancel. This would be negative 2. Okay. All right, does that make sense, Brainy? Okay. And now we're going to multiply again. So negative 2, I'm going to multiply it by the 4x and the -1. So we get negative 8x. Yep, once again, that's got to be the same. Negative 2 times 1 is positive 2. Okay. So when I subtract, well, what happens if I subtract the same thing? What do you get? If I have a number and I subtract that number, what do you get? 0. Okay? So if I have negative 8x plus 2 and I subtract this whole thing, which is itself, I'm going to get 0. Okay? Because when I distribute the negative, it would make this a positive and that a negative. So negative 8x plus 8x is 0. 2 minus 2 is 0. So 5x minus 2 would be my answer. All right, so that's long division. And a reminder, with long division, if my divisor has a coefficient of x, like this one has 4 as a coefficient of x, I have to use long division when I divide that. Okay? Synthetic division does not work in that case. Okay? You can do it, and you'll get an answer, but your answer won't be correct. It'll actually be need to be 4 times bigger. Okay? All right, so let's do a synthetic division one then. So here's number 6. X to the 4th minus 5x plus 10 divided by x plus 3. Is that the exact same problem we did in that example yesterday? Was it? That's what I thought. That looks like it. So, all right, well, we'll do it again. Okay. So remember, when we set up synthetic division then, first thing we're going to do is we're going to put this little backwards L, half a box, half a square, whatever, in this corner. And what goes in there is the 0 of the divisor. Okay? So what makes this 0? Okay? And that would be negative 3. Now, the one thing we're going to do today is we're going to do something called synthetic substitution. Okay? With synthetic substitution, they tell you what x is going to equal, so you'll use the number they give you, where in this case, when it says divide, then you have to find the 0 and use that. And that's where some people make a mistake, so you have to be careful about that. A note for your note card when we get there. Okay? Now, we're going to put along here then the coefficients. The coefficient of x to the 4th is 1, because there's only one of them. Now, you always have to have, every term must be represented. So if I start at x to the fourth, I must have x cubed represented, x squared represented, x, and a constant. Since there's no x cubed or x squared, I have to put zeros in to represent them. So basically, it's the coefficient of x to the fourth, coefficient of x cubed, because there's none of them, it's 0. Coefficient of x squared, since there's none of them, it's 0. Coefficient of x is -5, and then we have the constant is last, and that's +10. Okay, so we're listing the coefficients. Then we leave a space, draw a line, or if you're on notebook paper, I would just leave one line blank. Next thing we do is we bring down the leading coefficient. The leading coefficient is always going to be the same because I'm always dividing by 1x. Okay? So this would be a 1. Then we multiply. We're going to take our 0, multiply it by the number in this row now, and that number goes up here. So -3 times 1 is -3. And then I combine them. 0 plus -3 is -3. And then I do the same thing again. So now we're going to take -3, we're going to multiply it by the next number in that row. So -3 times -3 is 9. So then I add the column again. 0 plus 9 is 9. And we do it again. -3 times 9, -27. Okay. And unlike long division, we're just adding them together. We're not subtracting them. So -5 plus -27 is -32.
I didn't put a negative in front of it.
Right.
Found it.
Oh, good. So then I'm going to do it again. -3 times -32 is positive 96. Okay. Negative times a negative, positive. Add those together, we get 106. Now, so what's happening then is I'm taking a 4th degree polynomial and dividing a 1st degree polynomial, which means then I'm going to end up with a 3rd degree, or a cubic. So it's going to be 1x cubed, and then I just go down with my powers. Minus 3x squared plus 9x minus 32. And this number here, 106, is a remainder, so I will put that over x plus 3, my divisor. Okay, so there's long division and synthetic division again. So we're going to look at what they call synthetic substitution. Now with synthetic substitution, basically all they're doing is we're using the synthetic division process, but what it does is that if they give you a function and they ask you to evaluate it when x is 2, then basically all we're doing is putting 2 in for x and finding the answer. It's just another process for being able to do it, and actually one that's a little bit easier to do. So they say use synthetic substitution to evaluate the polynomial for the given value. In other words, if p of x equals 2x cubed plus 5x squared minus x plus 7, we want to know what does that equal when x is 2. So one way you've done that in the past is you would just take 2 and put it in for x and find the answer, right? Okay. So that's all we're doing here, okay? Or if I graphed it when x equals 2, this tells me what y equals when x equals 2. So it tells me the point on the graph when x is 2, what's the value of y? Okay? It's just that if you use synthetic division or synthetic substitution to do it, it's actually something that it's easier to do in your head without the use of a calculator. So when it says to use this number here, that's the number we're using. We're not using the opposite like we do when it says divide, okay? So when it says solve using synthetic substitution, you're using that number itself. You're not using the opposite like when it says to use synthetic division to divide. So we put 2 here, and then our coefficients. Bring down the 2. Multiply. Our number in our L here, 2 times 2 is 4. Add those together. 5 plus 4 is 9. 2 times 9 is 18. Add those together and I get 17. Okay, so we're taking this number here, and each time we're multiplying it by the number in this third row, and then it goes up into the second row, and we combine it. Okay, so 2 times 17 is 34, and 7 plus 34 is 41. And that is my answer. So if you put 2 in here for x, you would get 41. Actually, a little bit, I mean, maybe it looks like it's more writing, but easier to find this number than actually putting the 2 in there. Because sometimes if you get big powers, it gets large really fast, and it's hard to do that calculation in your head. Okay. So the answer in this case is 41. It's not 2x squared plus 9x plus 17 plus 41 over. Okay? Whatever the remainder is when we're doing synthetic substitution, that remainder is our answer. Okay? All right? Because we're not dividing to find the quotient. All right, so you want me to do this one, or you want to do it?
Nah, you can do it.
Mr. Grucky, you want to see another one? Okay, especially the fact that we put a fraction in there, right? Okay. So we're going to put negative 1/3 here. Because it says we're using negative 1/3, okay? It doesn't say divided by, it says we're using it. Then the coefficients. Coefficient of x to the 4th is 6. Coefficient of x cubed is negative 25. Missing x squared, right? So since there's no x squared, I have to put a 0 in for it. Negative 3, and then 5. So 2 things you have to remember. This must be in standard form for one thing, okay? Whenever I'm dividing or using synthetic substitution, it has to be in standard form, highest power to lowest. And if you're missing any terms, you've got to put a 0 in for it. Okay? Always bring down the first one. Bring down the 6. And we multiply. So hopefully what we're going to multiply by are multiples of 3, so multiplying by 1/3 actually is reasonably easy. So what's 1/3 of 6?
3, 2, 2. Definitely 2.
Definitely 2, Cody? Are you sure? You sure? Okay. All right. You got to think about that for a minute. Okay. Yell out one answer and then hope that everybody agrees with you. And if they don't, then pick another answer.
Negative.
Okay. So now since it's a negative, then we're going to put negative 2 here. Okay. Negative 1/3 times 6 is negative 2. Combine these two negatives, we still get a negative 27.
9.
He likes to talk a lot, doesn't he, Nick? Okay. All right. So 1/3 of 27, negative 1/3 times negative 27 is a positive 9. Combine those two. 0 plus 9 is 9. Actually, a nice number that works well with the fractions. 1/3 of 9 is what, Mr. Greca? 3. So in this case, it's going to be a negative 3. Negative 3 and negative 3 is negative 6. 1/3 of 6 is 2. 5 plus 2 is 7. And that's my answer. So if you put negative 1/3 in here for x, we're able, by using the synthetic substitution, that makes it able that we can actually do this process with our brain, okay, instead of having to rely on pieces of technology to help us, because we have pretty easy multiplication with that fraction. All right, one more, and then I'll let you go to work. Yep. Okay, we have a geometry application problem we're going to do. You're going to be doing more long division, more synthetic division, and these two.
But not very much.
Okay. About 35 of each. What? What's that?
Unless you're going to be like a nuclear technician or
A
something.
nuclear technician? You're not going to be a nuclear technician, Greca? Why not? Well, you know, doesn't matter. So, unfortunately, sorry, Spencer, that's just the way it is. You just got to get over it. Okay, which I know that probably won't happen, but that's okay. All right, write an expression that represents the area of the top face of a rectangular prism when the height is x plus 2 and the volume is x cubed minus x squared minus 6x. So we have a prism. This right here is a rectangular prism. All it is a box. Okay? And it says the height of this box is x plus 2, and the volume is x cubed minus x squared minus 6x. Find the area of the top. So how do I find the volume of a box?
Length times width times height.
Okay, length times width times height. Okay, so if I draw a box here, okay, rectangular. There we go. Close enough. Okay, there's a box. Not a very good one, but it'll work for our purposes, hopefully. Okay, so if this is here's a length, width, and height. Okay, and they tell me that the height in this case is x plus 2. How could I take the volume? So volume is equal to length times width times height. Okay, and it says find the area of the top. Well, what's the area of the top represented by?
Length times width.
Do you agree with that, Becca, that the area of the top is the length times the width? No? Okay. He's just shouting things out. You trust him?
Because the area is like a square.
Okay. Area is a square or a rectangle. How many of you agree with Cody that the area of the top is length times width?
Definitely. Yeah.
Okay. All right.
Speed.
All right. You should. Okay? Because to get the base of the box, the bottom or the top, is the length times the width. And then I'm going to multiply that by the height. Okay? So if I know the height and I know the volume, how can I find the length and the width? Divide them, okay? Because the length times width then would be equal to the volume divided by the height.
Nice.
Okay. Oh. So I have a division problem, and I can either use synthetic division or long division, or maybe it's something that's factorable, and I could use factoring to do it. Okay. So in the numerator, I would have x cubed minus x squared minus 6x, because that's the volume, and I'm dividing that by x plus 2. All right, so I'm going to take you through a factoring exercise then real quick, okay, to help you do this one. Oops. All right, first of all, when we're factoring, what's the first thing we look for? Okay, something they have in common, okay? So looking at the numerator, do they have anything in common? X, okay? So I can take that x out. So we have x times x squared minus x minus 6. So then can I factor this quadratic? X squared minus x minus 6. So when you're factoring a quadratic, okay, which you just did quadratics in chapter 5, okay, what are the factors of negative 6 that add up to negative 1? Okay, negative 3 and positive 2. So I could rewrite this as x times x minus 3 times x plus 2. Oh, hey, that works out nice then, because I have a factor of x plus 2 in the numerator, factor of x plus 2 in the denominator. So those two things can cancel, and I get x squared minus 3x is the area of the top. And I could even say that x could be the length and x minus 3 could be the width, couldn't I? Okay. All right. So on these problems here, and just like this one here, check it out, says write an expression for the length of a rectangle. All you're going to do is factor, okay? And then the thing that they don't have the same is going to be your answer, okay? So here we would have y minus 5 and y minus 9. Okay. If I factor y squared minus 14y plus 45, here I have y minus 9, so the other part would be y minus 5. Okay. You okay with that, Brandy? No. Says we have a rectangle. Here's the area. If this is y minus 9, what is the width? Okay, so we have to divide, but another way of dividing is you could just factor and cancel. Because I would have y minus 9 in the denominator, and then these would cancel and leave me with y minus 5. Okay. So some of you you're going to have to pull out your factoring skills for a little bit, and we'll be doing that later on also.